Something ancient and impossible has finally reached Earth, crashing into our sensitive detectors after a silent journey that began long before our solar system was even born. Astronomers are currently calling it a crisis, but that is a polite word for the terrifying realization that our entire history of the universe is fundamentally wrong. This is not a radio signal from a biological civilization, but a signature of light that simply shouldn't exist in a rational and orderly cosmos. It originated 13.5 billion years ago, emerging from the deep dark ages when the universe was supposed to be empty, silent, and dead. According to the standard model of cosmology, nothing in existence should have been capable of generating this much energy so soon after the Big Bang. Yet here it is, burning brightly on our sensors today, a ghost from a time that physics dictates should be a realm of absolute darkness. To understand the fear currently gripping the scientific community, you have to understand the sheer scale of the abyss this light has managed to cross. Every atom in your body was forged in a star, but this signal comes from a time before the first stars were theoretically supposed to ignite. We pointed the James Webb Space Telescope at a patch of nothingness, expecting to see the faint embers of creation, but we found something else. Instead, we found fully formed monsters staring back at us. Impossible giants that defy every computer simulation we have ever run on cosmic evolution. Imagine walking into a nursery and finding a fully grown man waiting in the crib. That is the level of impossibility we are currently facing. The data suggests that galaxies grew up instantly, bypassing billions of years of evolution, which implies a hidden catalyst we cannot see and do not understand. If the timeline of the universe is wrong, then our understanding of gravity, dark matter, and reality itself is built on a foundation of sand. The signal is a red shift of 14, meaning the light has been stretched by the expansion of space until it is barely a whisper. But the intensity of that whisper is screaming a warning. The early universe was not empty. It was crowded, energetic, and dangerously unknown. Some physicists are whispering about primordial black holes, ancient devourers that formed directly from the collapse of the Big Bang before atoms even combined. Could these impossible lights be the accretion disks of monsters feeding on the dense soup of the early cosmos, hiding in plain sight? If so, the seeds of our destruction were planted in the very first second of time, waiting specifically for this moment to reveal themselves to us. We are looking at objects that existed only 300 million years after the creation event, yet they look as mature as our own Milky Way. This creates a paradox known as the impossible early galaxy problem, and it is currently keeping cosmologists awake at night with its terrifying implications. It forces us to ask a chilling question. Is the universe older than we think? Or does time flow differently at the edge of reality? Perhaps the Big Bang was not the beginning, but merely a transition from a previous dead universe that left these scars behind for us to find. We call them galaxies, but they behave like engines, pumping out radiation at rates that violate the Eddington limit of standard stellar physics. The signal contains traces of heavy elements, carbon and oxygen, that simply should not exist yet in the cosmic timeline we have accepted as truth. Heavy elements are forged in the hearts of dying stars, requiring generations of stellar life and death to accumulate in any measurable quantity. Finding them this early is like finding a fossilized human skeleton inside a dinosaur egg. It breaks the narrative of history completely. Someone, or something, accelerated the process of creation, or we are fundamentally blind to the true mechanism that drives the evolution of the universe. The James Webb Telescope was launched to answer questions, but instead it has shattered the few answers we thought we had secured about our origins. We are now scrambling to patch the holes in the standard model before the entire framework of astrophysics collapses under the weight of this new anomaly. Look at the sky tonight and realize that the darkness is not empty. It is a curtain hiding a history we were never meant to see. The light hitting our sensors is ancient, yes, but its implications are urgent and terrifyingly present for the future of our species. If our calculations regarding the age of the universe are off by billions of years, then the predicted end of the universe is also wrong. We might be much closer to the heat death or the vacuum decay than any comfortable textbook has ever dared to suggest to the public. This is why the signal matters. It is not just history, it is a countdown clock that we have been misreading for over a century. The investigative team analyzing the spectrum found signatures that defy the logic of hydrogen fusion as we understand it in the modern era. Whatever power source lit up the early universe, it was cleaner, hotter, and faster than the stars that warm our planets today. Were these the fabled population 3 stars, giants made of pure hydrogen, or something darker that we have yet to name or classify? The silence from the scientific community is not a lack of data. It is the stunned silence of people realizing they were tragically wrong. We are drifting in a cosmos that is far stranger and perhaps far more hostile to our logic than we ever dared to imagine. Every time we peel back a layer of the dark, we find more questions staring back at us with cold, indifferent eyes. This signal is a breaker of chains, snapping the link between cause and effect that holds our sanity and our science together. If galaxies can exist before they are born, then the arrow of time might not be as straight as we perceive it to be. We are forced to consider the simulation hypothesis. Did the program load these assets prematurely before the physics engine was ready to handle them? Or are we looking at the wreckage of a previous cycle, the debris of a universe that died so ours could live and breathe? The truth is likely hidden in the gaps between the data, in the silence between the pulses of this impossible light reaching us now. As we stare into the deep field, we must accept that we are not the masters of this domain, but merely accidental tourists. The signal is a calling card from the precipice of existence, a reminder that our reality is a fragile island in a chaotic ocean. We are about to embark on a forensic analysis of this crime scene, dissecting the light to find the culprit behind the impossibility. Prepare yourself, because the answers we are finding do not offer comfort. They offer a stark, cold view of our insignificance. This is the story of the light that broke the universe, and the terrifying shadow it casts on our understanding of everything. To truly grasp the magnitude of this anomaly, we must first understand the instrument that found it, a machine designed to peer into the graveyards of the cosmos. The James Webb Space Telescope sits at the second Lagrange point, a solitary outpost of human engineering nearly 1 million miles from Earth, floating in the permanent shadow of our planet. It was built with a very specific purpose: to capture infrared light. This is not a stylistic choice. It is a requirement of cosmic archaeology. As the universe expands, it stretches the fabric of space-time itself, and any light traveling through that fabric gets stretched along with it. High-energy ultraviolet light emitted by the first stars billions of years ago has been pulled and warped during its journey to us, shifting down into the infrared spectrum. These photons are tired, ancient ghosts that are invisible to the human eye and invisible to the Hubble telescope. Webb is the only thing capable of seeing them, and when it opened its golden eye, we expected to see the faint, chaotic sparks of a universe just learning to light a fire. We expected dust. We expected confusion. We did not expect to see the impossible structure of a fully formed reality staring back at us. The specific signal that has caused this panic comes from a galaxy designated Jade's GSZ 13-0, a collection of stars that existed when the universe was merely 320 million years old. In human terms, if the universe were a 100-year-old man, this galaxy existed when he was a crying infant just a few days old. According to the Lambda CDM model, the standard model of cosmology that has been the bedrock of physics for decades, gravity simply does not work fast enough to build something this massive in such a short window of time. Gravity is a weak force. It takes eons to pull dispersed hydrogen gas into clouds dense enough to ignite fusion, and even longer for those stars to gravitationally bind into a galactic disk. Yet, the data from Jade's GSZ 13-0 shows a galaxy that is surprisingly bright, massive, and chemically complex. It is like finding a skyscraper built in the Stone Age. The bricks, the mortar, and the steel beams are all there, but the timeline of history says the tools to build them shouldn't exist for another 1,000 years. This isn't just a surprise. It is a violation of the laws of cause and effect. The implications of this discovery begin to dismantle our concept of dark matter, the invisible scaffolding that we believe holds the universe together. Under the current paradigm, dark matter forms a halo first, creating a gravity well that traps normal matter, allowing it to condense into stars. This process is slow, methodical, and mathematically predictable. Computer simulations of the early universe, running on supercomputers for months at a time, show a messy, turbulent beginning where small clumps of gas slowly merge over billions of years. But the signal from redshift 13 tells us that these simulations are wrong. The universe didn't stumble into existence, it exploded into structure almost instantly. This suggests that either our understanding of dark matter is fundamentally flawed, or there is another force at play, a catalyst that accelerated the birth of the cosmos. Some physicists are now whispering about self-interacting dark matter, a theoretical substance that doesn't just provide gravity, but actively herds normal matter into galaxies, acting like a shepherd dog rounding up sheep. If this is true, the invisible world is far more active and alive than we ever feared. We must also confront the terrifying possibility of primordial black holes. These are not the black holes formed from dying stars, but ancient singularities formed in the first fraction of a second after the Big Bang, created by the sheer density of the expanding plasma. If the early universe was peppered with these monsters, they could have acted as seeds for the early galaxies, pulling matter in at terrifying speeds. The light we are seeing from JADE's GSZ 13-0 might not be starlight at all, but the death scream of hydrogen gas being ripped apart as it falls into the event horizon of a primordial giant. This would solve the mass problem, but it introduces a new horror, a universe born from darkness, seeded with millions of invisible traps before the first atom was even formed. It paints a picture of a cosmos that was hostile from its very inception, a minefield of gravity wells waiting to consume the first light that dared to shine. We are not looking at a nursery, we are looking at a feeding ground. The investigative team analyzing the spectral lines of this ancient light found traces of oxygen and carbon, elements that astronomers call metals. In astrophysics, anything heavier than helium is a metal, and metals are only created in one place, the nuclear furnace of a star's core. When that star dies and explodes, it scatters these elements into the void to be recycled into the next generation of stars. This implies a cycle of life and death. But finding these elements at redshift 13 is paradoxical. It implies that countless generations of stars had already lived, burned through their fuel, and died in supernova explosions, all within a blink of cosmic time. How could the universe cycle through stellar generations so quickly? It suggests a frantic, hyper-accelerated era of existence, where stars lived fast and died young, burning with an intensity we simply do not see in the modern universe. We are looking at the ashes of a great fire that burned itself out before we were even a possibility, leaving us to wonder what fueled such a violent beginning. This anomaly forces us to question the cosmic ruler we use to measure distance and time. We measure the universe using the Hubble constant, a number that describes how fast the universe is expanding. But the tension between different measurements of this constant has been growing for years, and these new impossible galaxies are breaking the ruler completely. If the universe is expanding differently than we thought, or if the expansion rate has changed drastically over time, then our calculation of 13.8 billion years might be a comfortable fiction. What if the universe is actually twice as old? Doubling the age of the universe would give gravity enough time to build these monsters, solving the impossible galaxy problem. But the cost of that solution is catastrophic for physics. It would mean discarding the Big Bang theory as we know it, rewriting the history of every star and galaxy, and accepting that we have been misinterpreting the sky for a century. It would mean that we are not 13.8 billion years from the beginning, but perhaps lost in an eternity with no clear start and no clear end. Let us consider the Eddington limit, a hard physical barrier that dictates how fast a black hole or a star can grow. As matter falls in, it heats up and radiates light. That light exerts outward pressure, pushing against the infalling matter. If you feed it too fast, the light blows the food away. It is a self-regulating system, a cosmic choke point. But the supermassive black holes we are detecting in the early universe are too big to have grown within the Eddington limit. They defy the speed limit of feeding. To get this big this fast, they would have had to consume matter at super Eddington rates, gorging themselves without generating the pushback that physics requires. This implies a mechanism of direct collapse, where massive clouds of gas simply implode directly into a black hole without ever becoming a star first. Imagine a cloud of gas the size of a solar system blinking out of existence and being replaced instantly by a hole in reality. That is the violence required to explain this signal. The existence of these galaxies also threatens the Copernican principle. the idea that we are not in a special or unique place in the universe. We assume that the laws of physics here are the same as the laws of physics 13 billion light-years away. But what if they aren't? What if the speed of light, the strength of gravity, or the fine structure constant were different in the early universe? If the fundamental constants of reality can evolve or fluctuate, then science becomes a localized game, applicable only to our specific patch of space-time. The signal from the deep past might be evidence of a, quote, phase transition, a moment when the universe settled into its current, stable state, freezing the laws of physics into place. But if it froze once, it can melt again. This concept, known as vacuum decay, suggests a bubble of true physics could nucleate anywhere, expanding at the speed of light and rewriting the laws of nature, erasing us in the process. The signal is a hint that the ice we stand on is thinner than we think. There is a growing uneasiness among cosmologists that we are approaching the limits of what observational science can tell us. We are seeing the effects, but the causes are hidden behind a veil of time that is becoming opaque. The cosmic dark ages, the era before the first stars lit up, was supposed to be a time of simple, neutral hydrogen fog. But the data from Webb suggests that this fog was being pierced by intense radiation much earlier than predicted. This reionization event, where the universe went from opaque to transparent, seems to have been patchy, violent, and driven by sources we haven't fully identified. We are trying to reconstruct a crime scene where the footprints have been washed away by billions of years of cosmic expansion. The few footprints that remain, like Jade's GSZ 13-0, are giant, misshapen, and point in the wrong direction. We are detectives who have just realized the killer might still be in the room, hidden in the dark matter that surrounds us even now. The sheer number of these impossible galaxies is what truly disturbs the statistical models. If we had found just one, we could call it a fluke, a statistical outlier where everything went perfectly right for gravity. But we are finding them in every patch of sky we analyze. They are common. This means that the conditions for creating impossible objects were the standard conditions of the early universe. The anomaly is not the exception, it is the rule. This inversion of expectation suggests that our model of galaxy formation, hierarchical clustering, is missing a massive component. We are like cartographers who have mapped a coastline, only to find out that the ocean is actually land, and the land is actually ocean. The map is useless. We are sailing blind into a history that refuses to conform to our mathematics. And the more we observe, the more we realize that the universe is not a machine built for us to understand. It is a chaotic beast that barely tolerates our presence. Consider the energy density required to produce the light we are receiving. For a galaxy to be this bright at such a distance, it must be producing ultraviolet light at a rate that would sterilize any potential life forms instantly. These were not gentle, nurturing environments. The early universe was a place of extreme radiation, a cosmic sterilization chamber. If life tries to arise in such an environment, it is blasted apart by the very stars that should be nurturing it. This deepens the Fermi paradox, the question of why we are alone. Perhaps we are alone because the universe has spent the majority of its history being lethal. We might be the first survivors of a cosmic winter that lasted 13 billion years, emerging only now because the radiation has finally cooled enough to allow complex chemistry to hold together. We look at the sky with wonder, but we should look at it with the survivor's guilt of a species that made it out of the fire when nothing else could. The mystery deepens when we analyze the morphology, the shape of these ancient galaxies. In the standard model, early galaxies should be messy, irregular blobs of gas, colliding and merging in a chaotic dance. They should look like train wrecks. But the images from JWST show structured disks, spiral arms, and orderly rotation. They look calm, they look mature. How does a galaxy develop the elegant structure of a spiral arm in a fraction of the time it takes for the universe to even cool down? It is like watching a tornado assemble a house. The entropy, the disorder, of the early universe should be high, preventing such order from arising so quickly. The presence of these disk galaxies at high redshifts implies that order emerged from chaos with a speed that defies the second law of thermodynamics as we apply it to astrophysical scales. Something organized the universe before it had any right to be organized. One potential explanation involves dark energy, the mysterious force that is currently accelerating the expansion of the universe. We assume dark energy is a constant, a cosmological constant that does not change. But if dark energy was dynamic, if it was stronger or weaker in the past, it could have changed the friction of the expanding universe, allowing gravity to win battles it should have lost. This theory, known as early dark energy, solves the math but breaks the philosophy. It implies the universe has a throttle, a variable speed control that changes the rules of the game whenever it pleases. If dark energy fluctuates, then the future of the universe is not a slow freeze, but potentially a big rip, where the expansion becomes so fast that it tears atoms apart. The signal from the past might be the first warning shot that the throttle is stuck in a dangerous position. We must also talk about the halo mass function. In cosmology, this mathematical function predicts how many dark matter halos of a certain size should exist at any given time. It is a curve that has matched our observations for decades. The new data from JWST puts a bullet hole right through that curve. We are seeing more massive halos than the function allows. To fix this, we would have to tweak the initial conditions of the Big Bang itself, adding more power to the small-scale fluctuations that seeded the galaxies. But if we touch those initial conditions, we ruin the predictions for the cosmic microwave background, the afterglow of the Big Bang that fits our theories perfectly. We are stuck in a trap. We can explain the early universe, or we can explain the modern universe, but with our current physics we cannot explain both simultaneously. The two eras of time are in conflict with each other. This conflict creates a sense of cognitive dissonance in the scientific community. We are holding two contradictory truths in our hands. On one hand, the cosmic microwave background tells us the universe is 13.8 billion years old and composed of 5% normal matter, 27% dark matter, and 68% dark energy. On the other hand, the deep field galaxies tell us that the universe formed stars and structures instantly, efficiently, and with impossible speed. These two truths cannot coexist. One of them is a lie. And since the cosmic microwave background is the most precise measurement in the history of science, the fear is that our interpretation of the new data is correct, and the old data was masking a deeper complexity. We are like a person who has believed the Earth is flat, suddenly seeing the curvature of the horizon. The adjustment is not just mathematical, it is psychological. We are realizing we don't know where we live. Let's zoom in on the initial mass function of stars. This rule dictates how many small stars form for every massive star. In our local neighborhood, for every giant star, nature makes hundreds of small, dim dwarf stars. It's a pyramid scheme. But in these ancient galaxies, the light signature suggests the pyramid is inverted. They might be top-heavy galaxies, composed almost entirely of massive, screaming giants with very few small stars. A galaxy made entirely of monsters. If this is true, these galaxies would burn out in a flash, shining with the brightness of a trillion suns and then vanishing into darkness almost instantly. It would explain why they are so bright, but it paints a picture of a volatile, unstable early cosmos, where galaxies were like flashbulbs popping in the dark, brief moments of intense violence followed by eternal silence. It is a universe of boom and bust, on a scale we can barely comprehend. There is a chilling theory called tired light, originally proposed in the 1920s and long discarded, which suggests that the universe isn't expanding at all. Instead, light simply loses energy as it travels, shifting to red. For decades, this was considered pseudoscience, but as the impossible data piles up, some desperate theorists are dusting off these old ideas. If the universe isn't expanding, then the Big Bang didn't happen. The universe would be static and eternal, having existed forever. While most evidence still points to expansion, the fact that we are even reconsidering a static universe shows how desperate the situation has become. An eternal universe removes the creation event, but it replaces it with infinite time, an endless void where everything that can happen has happened, and we are just repeating a cycle that has occurred an infinite number of times before. This is the horror of the infinite loop. The James Webb Telescope is currently staring at a specific patch of sky known as the ultra-deep field. In this patch, we are hunting for population 3 stars, the hypothetical first generation of stars formed from pure primordial hydrogen and helium, with no metals. These stars have never been seen. They are the holy grail of cosmology. But the signal we received is metal-enriched. This means we missed the first generation. Even at redshift 13, we are too late. The first generation lived and died even earlier, hidden behind a wall of neutral hydrogen that we cannot penetrate. It implies that the dark ages of the universe were not dark. They were blindingly bright, filled with the explosions of these unseen ancestors. We are walking through a graveyard, looking for the first tombstone, only to find that the cemetery is built on top of an even older city of the dead that we can never excavate. What if the signal is artificial? I must clarify, no serious astrophysicist is claiming aliens. But as we reach the limits of natural explanation, the god of the gaps begins to shift. Not a deity, but a Type 3 civilization on the Kardashev scale. If a civilization arose in the very first billion years, unlikely but statistically non-zero, they could have engineered their galaxy, harvesting the energy of supermassive black holes. The impossible brightness and structure could be the result of mega-engineering Dyson swarms around an entire galactic core. While this is the realm of science fiction, the fact that natural laws are struggling to explain the data leaves the door slightly ajar for the unnatural. If the universe is optimized for life, perhaps it was optimized by life. But if they were there 13 billion years ago, where are they now? The silence of the modern universe becomes even more ominous if the past was teeming with giants. We are forced to confront the anthropic principle, the idea that the universe is the way it is, because if it were different, we wouldn't be here to see it. But this feels like a tautology, a circular argument that explains nothing. The impossible early galaxy problem challenges this. If the universe was hostile and chaotic, how did we survive the lottery? The fine-tuning argument says that if the density of the early universe was different by a fraction of a percent, it would have either collapsed back into a black hole or expanded too fast for stars to form. The data from JWST suggests the universe skirted this razor's edge with suspicious precision. It didn't just survive, it thrived immediately. It creates a feeling of vertigo, the realization that the universe is a rigged game, and we are the beneficiaries of a roll of the dice that had a 1 in a trillion chance of success. Or, perhaps, the game has been played 1 trillion times, and we are the only winners left to wonder why. Let's look at the Lyman alpha break, a spectral fingerprint that tells us when light is being absorbed by neutral hydrogen. This is how we date these ancient galaxies. The break in the spectrum of Jade's GSZ 13-0 is sharp and distinct. It confirms the distance beyond reasonable doubt. But it also confirms that the galaxy resides in a bubble of ionized gas. It has cleared the fog around it. To do this, it needs to be pumping out ionizing photons at an incredible rate. This galaxy is essentially terraforming the vacuum of space, carving out a cave of transparency in the dark wall of the early universe. This process, on a cosmic scale, is what melted the Dark Ages. But to see a single galaxy doing this so effectively, so early, suggests that these objects were not just passive participants in cosmic evolution, they were the drivers. They were the engines that burned away the dark. We owe our clear view of the night sky to these ancient monsters. The sheer density of stars in these early galaxies is another anomaly. In our Milky Way, stars are light years apart. In the core of Jade's GSZ 13-0, the star density is thousands of times higher. If you lived on a planet there, the night sky would not be black. It would be a blinding sheet of white fire. There would be no night. The radiation pressure alone would strip the atmosphere off any planet. It is a realm of pure energy. This density allows for stellar collisions, stars literally crashing into each other and merging. This dynamic is rare today, but back then, it might have been the norm. A universe of colliding suns, merging to form short-lived leviathans that exploded and polluted the cosmos with the elements of life. It was a violent, crowded mosh pit of stellar physics that makes our modern, spacious galaxy look like a deserted wasteland. There is a concept in physics called look-back time. When we look at the sun, we see it as it was 8 minutes ago. When we look at Jade's GSZ 13-0, we see it as it was 13.5 billion years ago. We never see the now. We are trapped in a sensory delay. But the terrifying part is that Jade's GSZ 13-0 is gone. It doesn't exist anymore. The stars that generated that light have burned out, exploded, or fallen into black holes billions of years ago. We are studying a ghost. The galaxy has likely merged with others, evolving into a massive elliptical galaxy that is currently dead and red, floating somewhere in the dark, far beyond our horizon. We are receiving a postcard from a dead relative. The reality of that galaxy now is completely inaccessible to us. We are connected by a thread of light, but separated by an ocean of time that can never be crossed. The universe is a graveyard of things that used to be. The data is stored on secure servers, analyzed by scripts, and debated in conference halls, but the raw numbers are chilling. The redshift $Z equals $13.20. The mass $M equals 10 to the power of $9 solar masses. The star formation rate, 50 solar masses per year. For context, our Milky Way forms only 1 or 2 stars a year. This ancient galaxy was a factory, churning out stars at a frenzy. This starburst phase is usually triggered by a collision with another galaxy. But in the early universe, everything was moving away from everything else due to expansion. How did enough matter collide to trigger this frenzy? It implies that the early universe was clumpy in a way that contradicts the smoothness of the cosmic microwave background. It's another paradox. Smooth background, clumpy foreground. The math doesn't add up. Someone is lying to us. Either the light, or the gravity, or our own limited brains. We are beginning to suspect that black holes might play a much larger role in the structure of the universe than we thought. We used to think they were rare anomalies. Now we think they might be the skeleton. If every galaxy has a supermassive black hole at its center, and these black holes formed first, then the galaxy is just the clothing the black hole wears. The signal from 13.5 billion years ago might be the light of the clothing being put on. This flips the script. Stars didn't form galaxies and then make black holes. Black holes formed and then trapped stars. We are living in a universe defined by its drains, not its fountains. We orbit the drain. The Earth orbits the Sun. The Sun orbits Sagittarius A, the supermassive black hole at the center of the Milky Way. We are all, ultimately, just debris waiting to be consumed, circling the event horizon on a timeline of billions of years. The discovery of these objects has sparked a crisis in cosmology. This isn't media hype. It is the technical term used in peer-reviewed papers. The Hubble tension, the sigma-8 tension, and now the high redshift galaxy problem. These are cracks in the dam. The standard model is leaking. Scientists are scrambling to propose new physics, extensions to the laws of nature, modifying gravity, MOND, introducing decaying dark matter, proposing oscillating universes. It is a time of chaos in the theoretical world. We are watching the scientific consensus fracture in real time. For the public, it sounds like progress. For the experts, it feels like the ground is dissolving. We spent 50 years building a house, and now we found out the foundation is liquid. The universe is proving to be far more elusive than our equations can handle. Imagine the light from this galaxy traveling through the void. For the first billion years, it flies through the expanding dark. Then it passes through the epoch of galaxy formation, dodging the gravity of newborn clusters. It travels through the vast voids, the empty spaces between the cosmic filaments. It travels while the Earth forms from dust. It travels while single-celled life evolves. It travels while the dinosaurs rise and fall. It travels while humanity invents fire, writing, and the telescope. Finally, it ends its journey by smashing into a beryllium mirror coated in gold, 1,000,000 miles from Earth. The journey is over, the message is delivered. But the message is in a language we are struggling to translate. It says, "I was here before you were possible, and I was greater than you can imagine." It is a humbling, terrifying testament to the deep time that crushes all human achievement into insignificance. Could it be that our location in the universe is obscuring the truth? We live in a generic spiral galaxy, in a generic local group, but we are observing the universe through the zone of avoidance, the thick band of dust in our own Milky Way that blocks 20% of the sky. We are trying to understand the room while wearing a blindfold over one eye. The signal from Jade's GSZ-13-0 managed to sneak through a clear patch, a keyhole in the dust. How many other signals are blocked? How many monsters are hiding behind the core of our own galaxy? invisible to us. We are mapping the universe based on what we can see, but the shadow universe, the parts obscured by dust and gas, might contain the answers that would solve these paradoxes. We are assuming the part we see is representative of the whole. That is a dangerous assumption. The instrumentation of the James Webb Telescope includes the NIR SPEC, near-infrared spectrograph. This device has microshutters, tiny doors the width of a human hair that can open and close to let in light from a single target while blocking out neighbors. It allows us to isolate the signal from the noise. When NIR SPEC looked at this ancient target, it broke the light into a rainbow of data. That rainbow showed the spectral fingerprints of hydrogen and oxygen. The shift of these lines to the red end of the spectrum is the definitive proof of the object's age. There is no ambiguity in the measurement, only in the interpretation. The numbers don't lie, but they tell a story that sounds like a lie. We are staring at the truth, and it looks impossible. This is the definition of a paradigm shift. When the facts refuse to fit the theory must die. As we continue to stare into the abyss is starting to look crowded. New candidates are popping up. Galaxies at redshift 16, even redshift 20. These are candidates that push the timeline back to just 200 million years after the Big Bang. If confirmed, these would break the standard model beyond repair. At 200 million years, the universe was still cooling down from the initial fireball. For a galaxy to exist there is like finding an ice cube in a furnace. It shouldn't happen. If these candidates are real, it suggests that structure in the universe is not an emergent property that happens slowly, but an intrinsic property that was baked in from the start. The universe didn't become structured. It was born structured. This hints at a pre-Big Bang order, a blueprint that was carried over from whatever came before. Let's discuss the concept of information loss. As light travels these vast distances, it interacts with the intergalactic medium. Some photons are scattered, some are absorbed. The image we get is degraded, like a low-resolution JPEG downloaded over a bad connection. We are trying to reconstruct the face of the early universe from a pixelated, blurry image. Is it possible that the smoothness we see in the older galaxy shapes is an illusion caused by this blurring? Perhaps they are chaotic messes, but we can't see the details. Or perhaps the blurring is hiding something else. Binary black hole systems, jets of plasma, or dual cores. We are reaching the limit of resolution. We are squinting at the dawn of time, and our eyes, even our $10 billion golden eye, might not be sharp enough to see the fine print of creation. And the fine print is where the devil usually resides. The great filter is a concept usually applied to life, but what if we apply it to galaxies? Maybe the early universe produced billions of these massive, dense galaxies, but most of them destroyed themselves. Maybe they collapsed into supermassive black holes and went dark. Maybe the radiation they produced blew them apart. The galaxies we see today, like the Milky Way, might be the runts of the litter, the slow-growing, stable ones that didn't burn out in the first epoch. We look at Jade's GSZ 13-0 and see a titan, but perhaps we are looking at a doomed species of galaxy that went extinct billions of years ago. We are the descendants of the survivors, the slow and steady ones. The fast and the furious are all gone, leaving only their ghosts in the infrared light to remind us of their glory and their destruction. What if the redshift is not just velocity? There is a fringe theory, but one that gains traction in the dark corners of astrophysics: variable speed of light. If the speed of light was faster in the early universe, it would allow parts of the cosmos to communicate and organize much faster than they do today. It would solve the horizon problem and the impossible galaxy problem in one stroke. But if the speed of light can change, then $E equals mc² is not a constant. Energy and matter would have a different relationship in the past. The nuclear reactions in stars would be different. The very binding energy of atoms would be different. It would mean the past is not just a different time. It is a different universe with different physics. We are looking back at an alien dimension that slowly cooled and froze into the reality we know today. The signal also carries clues about the temperature of the intergalactic medium, the gas between the galaxies. In the early universe, this gas was hot, dense, and opaque. The light from Jade's GSZ 13-0 had to punch through this medium. The fact that we see it implies the galaxy created a Stromgren sphere, a bubble of ionized, transparent gas around itself. It was pushing back the dark. This battle between light and the dark fog was the defining conflict of the first billion years. We are seeing the muzzle flash of a weapon used in a war against opacity. The universe wanted to remain dark. Gravity and fusion fought to make it bright. It is a primordial struggle, and we are the beneficiaries of the victory of light. But the dark is patient. Entropy ensures that eventually, the dark will win again. We are living in the brief interlude of light. We must also consider the bias of our detection methods. We find the brightest things because they are the easiest to see. This is called Malmquist bias. We might be looking at the freakish monsters of the early universe and assuming they are normal, simply because we can't see the trillions of normal, faint galaxies that are also there. We might be judging the population of a city by only looking at the giants, but even if Jade's GSZ-13-0 is a freak, a 1 in a billion monster, the fact that it exists at all is the problem. You don't need a population of giants to break the laws of physics. You only need one giant in a room that has a ceiling too low to accommodate him. One impossible object is enough to disprove a theory, and we have found more than one. The philosophical weight of this discovery cannot be overstated. For centuries, science has moved us away from the center. The Earth is not the center of the solar system. The Sun is not the center of the galaxy. The galaxy is not the center of the universe. Now, we are learning that our time is not the center of history. The most exciting, dynamic, and violent era of the universe happened long before we arrived. We missed the party. We are walking through the ruins of a civilization of stars that was far grander and more terrifying than anything we will ever experience. It creates a sense of a realization that we are the latecomers, the scavengers living on the scraps of energy left over from the big beginning. The glory days of the cosmos are over. We are watching the end credits. The data from the signal is currently being fed into new simulations, hydrodynamic simulations, that try to model gas flow in the early universe. The computers are struggling. To replicate the formation of Jade's GSZ-13-0, the simulations require us to tweak the feedback loops, the way supernova explosions push gas out of a galaxy. We have to turn the feedback off. We have to assume that early supernovae didn't blow the gas away, but somehow the gas stayed and formed more stars. This maximum efficiency model is the only way to make the math work. But why would supernovae behave differently back then? Why was the gas stickier? It implies a fundamental difference in the viscosity or the magnetic fields of the primordial plasma. Again, we are inventing new properties of matter just to keep our theories alive. It is a desperate fix. There is a haunting beauty in the images. We assign them false colors, red for infrared, blue for shorter wavelengths. But the reality is invisible heat. If you were floating in space near Jade's GSZ-13-0, your eyes wouldn't see the galaxy as we see it. You would be cooked by the infrared radiation, but the visual light would be shifted out of your perception. You would be dying in the dark, feeling the heat of invisible ghosts. It is a reminder that our senses are limited. We evolved to see the light of our specific yellow sun, filtering through our specific nitrogen-oxygen atmosphere. The universe is not built for our eyes. It is full of lights we cannot see, sounds we cannot hear, and forces we cannot feel until they destroy us. The JWST is our prosthetic eye, allowing us to glimpse the true, hostile nature of reality. The collaboration required to analyze this signal spans the globe, thousands of scientists. But the consensus is fragile. There are factions forming. The modified gravity faction, the early dark energy faction, the primordial black hole faction. This signal has turned cosmology into a battlefield of ideas. And in every battle there are casualties. Old theories are dying. The careers of scientists who spent decades refining the lambda CDM model are being threatened by a few pixels of red light. It is a scientific revolution in motion. We are watching the paradigm shift that Thomas Kuhn wrote about. The anomaly has appeared. The crisis is here. The old guard is fighting to explain it away, but the young guard is looking for a new theory of everything. The universe is forcing us to grow up. Let's talk about the void, the space between these galaxies. It is not empty. It is filled with the intergalactic medium, filaments of gas that connect the galaxies like a cosmic web. The signal from the early universe had to traverse this web. We are studying the shadows the web casts on the light. These absorption lines tell us the chemical composition of the nothingness. And even the nothingness is weird. It is enriched with carbon. How did the empty space get polluted with carbon so early? It implies that the first galaxies were messy eaters, spewing their guts out into the void, polluting the entire universe with the ashes of their dead stars. We are breathing that ash today. The carbon in your DNA was likely forged in one of these impossible early galaxies, blown out into the void, and recycled billions of years later into our solar system. We are made of the debris of the anomaly. The future of this investigation lies in spectroscopy. We need deeper spectra. We need to stare at this dot for hundreds of hours. We need to count the individual photons. Every photon carries a timestamp and a location stamp. We are reconstructing a 4D map of the universe, 3 dimensions of space, and 1 of time. But the map has a dragon in the corner. Jade's GSZ130 is the dragon. It warns us that here be monsters. As we push the map further back, towards the Big Bang, we expect to find more dragons. The Dark Ages might turn out to be the age of giants. And if that's true, we need to ask, what killed the giants? Why is the universe today so quiet and small compared to the era of the Titans? Did they consume all the easy fuel? Did they starve themselves to death? Or did something else clear the board? The psychological impact of deep time is profound. When we say 13.5 billion years, the number is abstract. It means nothing to a brain that evolved to track seasons and lifespans. But try to visualize it. Every year is 31 million seconds. Multiply that by 13.5 billion. The sheer scale of the boredom of the universe is crushing. For most of that time, nothing happened. Gas cooled. Stars burned. Gravity pulled. It is a machine that grinds slowly. But the signal tells us that the beginning was not slow. It was explosive. The universe didn't wake up groggy, it woke up screaming. The violence of the first epoch sets the tone for everything that follows. We exist in the cooling embers of that initial explosion. We are the heat death in slow motion. The excitement happened long ago. As we peer closer to the Big Bang, we approach the singularity, the point where math breaks down. But these galaxies are uncomfortably close to that point. They are existing on the edge of the breakdown. If we find a galaxy at redshift 20, we are mere millions of years from the start. It raises the question, was there a before? If galaxies can form instantly, maybe the seeds were planted before the Big Bang. Maybe the Big Bang was not a beginning, but a bounce. A big bounce from a previous collapsing universe. These impossible galaxies could be the survivors, the black holes from the previous universe that punched through the singularity and survived into ours. It sounds like madness, but Penrose's conformal cyclic cosmology predicts exactly this kind of anomaly. Ghost circles from the eon before. We might be looking at artifacts from a dead universe. The James Webb Deep Field images are beautiful, filled with jewels of light. But remember what you are seeing. You are seeing the combined output of trillions of nuclear explosions. You are seeing gravity crushing matter until it ignites. You are seeing the destruction of matter to create energy. It is a violent beauty. And among those jewels is the red dot of Jade's GSZ130, a bloodstain on the fabric of space. It is the most distant thing humans have ever seen. It is the edge of our reality. Beyond it lies the opaque wall of hydrogen, and beyond that, the fireball of creation. We have stared to the edge of the cliff. We are looking for answers, but the abyss is silent. It only offers us more questions, and the uneasy feeling that we are very, very small. The standard model of particle physics is also at stake here. It describes the fundamental particles, quarks, leptons, bosons. But it doesn't explain gravity. It doesn't explain dark matter. It doesn't explain the mass of the early galaxies. We are trying to fit a square peg into a round hole. The anomaly is the hammer that is smashing the peg. We might be on the verge of discovering a new particle, the axion, or a sterile neutrino, something that acted as the glue for these early structures. If we find it, it will rewrite textbooks. If we don't, we are left with a mystery that defies logic. The stake is the very description of reality. We thought we had the recipe for the universe, but we just found an ingredient we don't recognize, and it's the main flavor of the dish. What if the universe is a hologram? The holographic principle suggests that all the information in the universe is encoded on the 2D surface of the boundary, and the 3D reality we perceive is a projection. If this is true, the impossible galaxy might be a glitch in the projection, a rendering error. When a video game loads, sometimes objects pop in before the texture maps are ready. Is Jade's GSZ130 a pop-in artifact? It's a wild speculation, but when the standard physics fails, the wild speculations are all we have left. We are probing the code of the cosmos, and we found a bug. And usually, where there is one bug, the whole system is unstable. We must return to the dark matter problem. We assume dark matter is cold, moving slowly. This is the cold dark matter, CDM model. It works for big structures, but for these early, small, dense galaxies, maybe dark matter was fuzzy. Fuzzy dark matter consists of ultralight particles that behave like waves. They can pile up and create dense cores much faster than cold particles. This quantum behavior on a galactic scale could explain the anomaly. It would mean the galaxy is a giant quantum object, a Bose-Einstein condensate, the size of thousands of light years. A single quantum wave function spanning a galaxy. The weirdness of quantum mechanics, usually confined to atoms, might be the architect of the largest structures in the universe. The Tolman surface brightness test is another way to check if the universe is expanding. In an expanding universe, surface brightness should dim rapidly with distance. In a static universe, it stays constant. The data from these high redshift galaxies is ambiguous. They are brighter than they should be. While expansion is still the best theory, the brightness tension is another headache for cosmologists. The universe is refusing to fit the curve. Every test we throw at Jade's GSZ130 comes back with a result that says error. It is the ultimate outlier. It is the piece of the puzzle that doesn't fit, no matter how hard we hammer it. And usually, when a piece doesn't fit, it belongs to a different puzzle entirely. Let's consider the observer effect. In quantum mechanics, measuring a system changes it. Does observing the early universe change it? No, that's magical thinking. But our interpretation changes our past. History is not fixed. It is a narrative we construct from the available evidence. The arrival of this signal has rewritten our history. Yesterday, we lived in a universe that grew slowly. Today, we live in a universe that was born fully formed. The past has changed. And if the past can change based on new data, then our origin story is fluid. We are adrift in a narrative that is being edited in real time. We don't know where we came from anymore. And if you don't know where you came from, you don't know who you are. We end this phase of the investigation with a sobering thought. The light from Jade's GSZ13-0 is 13.5 billion years old. It left its source when the universe was a toddler. It traveled across the expanding silence for an eternity. It arrived here on a small blue planet orbiting a mediocre star to be caught by a mirror made by apes who just learned to split the atom. The probability of this connection is 0, yet it happened. We are holding the oldest photograph in existence. It shows us a monster. And the monster is telling us that the universe is older, stranger, and more terrifying than our dreams. The signal has been received. Now, we must decide what to do with the knowledge that we are living in a cosmos that defies our rules. The investigation is just beginning. We must dive deeper into the chemical composition of this impossible signal, for therein lies a specific terror that keeps astrophysicists awake. The universe began with a simple periodic table: hydrogen, helium, and a trace of lithium. That was it. Every other element, the carbon in your cells, the oxygen in your lungs, the iron in your blood, is stardust, cooked in the nuclear infernos of stars and scattered by explosions. This process takes time. It takes billions of years of stellar evolution to pollute the cosmos with enough heavy metals to form a planet like Earth. Yet, the spectrum of Jade's GSZ 13-0 reveals significant amounts of these metals. This is the metallicity problem. Finding a metal-rich galaxy at the dawn of time is like finding a modern smartphone buried in a tomb from ancient Egypt. It implies that a massive, unrecorded generation of stars lived, burned, and died with frantic speed before this galaxy even formed. We are missing an entire chapter of history, the chapter where the universe was poisoned with the seeds of life. We are staring at a crime scene where the weapon has already been melted down and recycled. This missing chapter leads us to the theoretical monsters known as Population 3 stars. These were the first stars, born from the pristine, metal-free gas of the Big Bang. Because they lacked metals to cool them down, they could grow to terrifying sizes, hundreds, perhaps thousands of times the mass of our Sun. A Population 3 star would be a blue giant of unimaginable power, burning its fuel millions of times faster than a normal star. They would have lived for only a few million years, a blink of an eye in cosmic terms, before detonating in pair instability supernovae, explosions so violent they leave nothing behind, not even a black hole. They completely vaporize themselves. The metal detected in the ancient signal is the ash of these suicides. We have never seen a Population 3 star because they all died before we could look. We are living in a universe built on the graveyards of these titans, and the impossible brightness of the early galaxies might be the final afterglow of their collective self-destruction. Consider the epoch of reionization, the period when the universe went from being a dark fog of neutral hydrogen to the clear, transparent void we see today. We used to think this was a gradual process, like mist burning off in the morning sun. But the presence of these massive, bright galaxies suggests it was a violent, patchy event. These galaxies were like blowtorches, blasting holes in the cosmic fog with intense ultraviolet radiation. But to clear the fog so quickly, they would have needed to leak almost 100% of their ionizing radiation into the intergalactic medium. Modern galaxies are selfish. They keep most of their radiation inside to heat their own gas. These ancient galaxies were leaky, spewing their energy outwards in a desperate attempt to terraform the universe. It paints a picture of a hostile environment where galaxies were fighting a war against the dark, burning themselves out to carve a pocket of transparency in the suffocating gloom of the early cosmos. We must also question the lens through which we view these monsters. Gravity bends light. This is gravitational lensing. Massive galaxy clusters between us and the early universe act as natural telescopes, magnifying the light from behind them. This is how we see Jade's GSZ 13-0. But lenses can distort, they can warp, they can create illusions. There is a fear, a lensing bias, that we are misinterpreting the magnification. If the lens is not perfectly smooth, if it has subhalos of dark matter, it could magnify a tiny normal star cluster and make it look like a giant galaxy. We might be looking at a funhouse mirror reflection and calling it a monster. However, multiple verifications suggest the magnification is real, which brings us back to the horror. Even after correcting for the lens, the object is still too big. The universe is not tricking us with mirrors. It is frightening us with facts. The monster is real, and it is huge. The spin of these galaxies presents another paradox. In the Standard Model, galaxies gain their spin through tidal torques, the gravitational tug-of-war with their neighbors as they form. This spin-up process takes billions of years. A galaxy starts as a blob and slowly spins into a disk. But Jade's GSZ 13-0 and its cousins appear to be disk-like already. They are spinning in an orderly fashion. How did they acquire this angular momentum so quickly? It implies they were born spinning. This suggests the primordial gas clouds had a tremendous amount of rotational energy from the start. Where did that energy come from? Was the Big Bang itself a rotating event? If the entire universe has a net spin, it would violate the cosmological principle of isotropy, the idea that the universe looks the same in all directions. A spinning universe would have a preferred axis, a God axis, we would be living in a giant tornado, not a static bubble. Let's discuss the seed problem of supermassive black holes. To get a black hole 1 billion times the mass of the Sun, you need a seed. Standard physics says the seed is a dead star, maybe 10 to 100 solar masses. You then feed it gas. But black holes are messy eaters. They vomit out energy that blows away the food. There is a maximum speed limit to their growth. The black holes powering these early quasars are too big to have grown from stellar seeds. The math simply forbids it. You cannot eat that fast. This forces us to accept the direct collapse theory. This is where a cloud of gas, millions of times the mass of the Sun, does not fragment into stars. Instead, kept hot by radiation from nearby galaxies, it collapses monolithically, all at once into a single point. A black hole of 1 million solar masses is born in 1 second. No star, no explosion, just a sudden, silent punch through the fabric of space-time. A hole that was never a star. The implications of direct collapse black holes are terrifying for the potential of life in the early universe. To form a direct collapse black hole, you need to suppress the formation of molecular hydrogen, which is the coolant that allows stars to form. You need to keep the gas hot. The only way to do that is to bathe the cloud in intense, sterilizing ultraviolet radiation from a nearby neighbor galaxy. So for one monster to be born, it requires a neighbor to sterilize it. It is a cosmic murder-suicide pact. One galaxy kills the star-forming potential of another, forcing it to collapse into a singularity. This suggests the early universe was a cannibalistic environment, where galaxies triggered the destruction of their neighbors to birth these leviathans. It was not a garden, it was a gladiator pit where only the most violent structures survived the initial epic. There is a concept called cosmic variance. It basically means bad luck. It is possible that we, sitting here in the Milky Way, happen to be looking out into a weirdly overdense direction of the universe. Maybe the rest of the universe is empty and normal, and we just happen to be staring down a filament of the cosmic web that is exceptionally crowded. We might be drawing conclusions about the whole ocean based on one teeming reef, but as JWST points in different directions, north, south, the deep field, the SMACS cluster, it finds the same thing. The monsters are everywhere. The bad luck argument is failing. We are not in a special spot. The universe is uniformly impossible. This consistency removes the comfort of being an anomaly. We are not the exception. The standard model is simply wrong about the rule. The universe is teeming with giants where there should be dwarfs. The energy output of these galaxies challenges the baryon efficiency limit. Baryons are normal particles, protons and neutrons. In modern galaxies, only about 10% to 20% of the available gas actually turns into stars. The rest gets blown away or stays hot. It's an inefficient process. To explain the brightness of Jade's GSZ130, we have to assume a baryon efficiency of nearly 100%. This means almost every atom of gas in that galaxy was successfully turned into a star. This is perfect star formation. Nature is rarely perfect. Entropy usually ruins efficiency. For a galaxy to be 100% efficient implies a mechanism of containment we don't understand. Perhaps strong magnetic fields or dark matter cages that refuse to let the gas escape. It suggests a level of determinism in the early universe, where matter was compelled to become stars with a mechanical, industrial precision that we do not see today. Let us consider the sound of the early universe. Before there were stars, the universe was a hot plasma filled with sound waves, baryon acoustic oscillations. These were pressure waves traveling through the soup of particles. As the universe expanded and cooled, these waves froze in place. The peaks of the waves became the seeds of galaxies. The troughs became the voids. We can see this pattern in the distribution of galaxies today, but the impossible galaxies are too big for the sound waves that should have seeded them. They are like loud booms in a room that should only support whispers. This implies that the music of the Big Bang contained frequencies, harmonics, that our theories missed. The initial shout of creation had a deeper, heavier bass note that clumped matter together faster than we predicted. We are listening to a recording of the Big Bang and realizing we missed the bass drop. The dark energy question returns with a vengeance. If the early universe formed structures this fast, It implies that the expansion force, dark energy, was weaker back then, allowing gravity to win. But if dark energy can change strength, it is a dynamical field, a quintessence. A changing dark energy field could eventually reverse. It could turn from expansion to contraction. The Big Crunch is back on the table. Or worse, it could become negative, triggering a rapid collapse of the universe in a big slurp. The stability of our future depends on the constancy of this force. The anomaly at redshift 13 suggests that the force is not constant. The engine of the universe has gears, and we just heard it shift. If it shifted once, it can shift again. We are passengers in a vehicle with a driver who is erratic and unpredictable. There is a disturbing parallel with the ultraviolet catastrophe of the late 19th century, where classical physics failed to explain black-body radiation. That failure led to quantum mechanics, a total rewrite of reality. The impossible galaxy problem is the ultraviolet catastrophe of the 21st century. We are standing on the precipice of a new physics. This new physics might involve extra dimensions. String theory posits 10 or 11 dimensions. Perhaps gravity is leaking into these extra dimensions, which is why it seems weak today. But maybe in the early universe the dimensions were tighter, and gravity was stronger. If gravity was 10% stronger in the past, these galaxies are easy to explain. But a variable gravity means the laws of physics are time-dependent. The constants are variables. It unmoors us from certainty. We are building skyscrapers on a foundation that shifts every few billion years. What if the signal is a warning about the false vacuum? The Higgs field, which gives particles mass, might not be in its lowest energy state. It might be in a metastable state, like a ball resting on a ledge halfway down a hill. The violent conditions of the early universe, the high energies, the dense black holes, could have triggered localized vacuum decay events. Some theories suggest that the Big Bang itself was a vacuum decay event. The impossible galaxies might be scars from failed nucleation bubbles, places where the universe tried to change state but was arrested. We look at them as galaxies. Maybe we should look at them as scabs. Scabs over wounds where the fabric of reality almost tore open. If a new bubble nucleates today, it expands at the speed of light, deleting physics as it goes. The warning from the past is that the fabric is stressed. The dust problem creates another layer of obfuscation. Dust absorbs blue light and re-emits it as infrared. We assume we understand the attenuation curve, how dust blocks light. But if the dust in the early universe was different, made of silica or diamonds produced by exotic stars, it would change our measurements of mass and age. Diamond dust sounds poetic, but in astrophysics it is a headache. Exotic dust grains could mimic the signal of a massive galaxy while actually hiding a smaller, stranger object. But to make exotic dust, you need exotic stars. We are back to the same problem. You need a generation of monsters to create the dust that hides the monsters. The circular logic traps us. No matter how we interpret the data, we need a precursor generation that was violent, massive, and incredibly fast. The universe started with a bang, but the echo is louder than the explosion. We are also finding quiescent galaxies in the early universe. These are dead galaxies. They formed stars, used up all their gas, and turned off, all within 500 million years. To kill a galaxy that fast is incredibly difficult. You need to heat the gas so much it can't cool down, or blow it all away. This usually requires a supermassive black hole in quasar mode, shining with the brightness of 1 trillion suns to scour the galaxy clean. Finding dead galaxies this early means the murder happened almost immediately. The universe built a city and nuked it before the first billion years were up. It reinforces the idea of a boom-bust cycle. The early universe was not a cradle of life. It was a slaughterhouse where galaxies were born, grew to gigantic sizes, and were strangled by their own black holes in record time. We are looking at the corpses. The Jeans mass is the critical mass needed for a cloud of gas to collapse under gravity. In the early universe, the gas was hotter, so the Jeans mass was higher. It should have been harder to form small things. Only big things should have formed. This aligns with the massive galaxies we see. But it contradicts the hierarchical model, where small things form first. The physics of the Jeans mass suggests the universe started with the top-down formation, giant pancakes of gas breaking into galaxies, rather than bottom-up. This old theory, Zeldovich's pancake theory, was discarded decades ago. Now the zombie is clawing its way out of the grave. If the universe formed top-down, then the largest structures are the oldest, and the fine details, like stars and planets, are late-stage fragmentation. We are the crumbs falling off the table of the giants. The James Webb is an infrared time machine, but it has a limit. It cannot see before the surface of last scattering, the cosmic microwave background, CMB. That is a wall of fire at redshift 1100. We can never see past it with light. But the impossible galaxies at redshift 13 are hinting that what lies behind that wall is not what we thought. The CMB shows a smooth universe. The galaxies show a clumpy one. The transition between the two is the Dark Ages. Somewhere in the dark, the universe broke its symmetry. The mystery lies in that transition. It is like walking into a room and seeing a vase shattered on the floor, but the security camera footage from a minute ago shows the vase perfectly intact. What happened in the minute the camera blinked? The monster walked in. The monster is the physics of the Dark Ages. Let's speculate on primordial non-Gaussianity. This is a fancy way of saying the dice were loaded. In a standard random distribution, Gaussian, extreme events, like giant galaxies, are rare. In a non-Gaussian distribution, extreme events are common. The tails of the bell curve are fat. If the primordial quantum fluctuations were non-Gaussian, it means the universe was born with a preference for the extreme. It favored the creation of monsters. This would solve the math. But it raises a question about the inflation field that expanded the universe. Why was it non-Gaussian? What kind of exotic energy field prefers to create giants? It implies a chaotic, turbulent inflation, not the smooth, graceful expansion we teach in school. The birth of the universe was a violent, messy tearing of space-time that left scars. We call those scars galaxies. The connection to the Great Attractor must be noted. We know our own galaxy is being pulled towards a gravitational anomaly hundreds of millions of light years away. We can't see it because it's behind the Milky Way. But gravity feels it. The early universe signals show similar flows, vast rivers of galaxies flowing towards something massive, something dark. These dark flows defy the explanation of the expanding universe, which should scatter things apart. Instead, things are rushing together. Are there hypermasses out there? Concentrations of matter so vast they tilt the entire universe. If Jade's GSZ 13-0 is just a small piece of a larger flow, then we are like debris caught in a riptide, unaware of the dark ocean we are being dragged into. The universe has currents, and we are not swimming. We are drifting. The simulation hypothesis is often dismissed as pop philosophy, but the computational limits of the universe are a serious study. Digital physics. If the universe creates complexity too fast, like these galaxies, it stresses the processing power of the simulation. In video games, procedural generation takes time. If you move too fast, the terrain glitches. Are these impossible galaxies glitches, where the procedural generation of the cosmos failed to keep up with the expansion rate? Did the code just copy-paste mature galaxies into the early epoch to save memory? It sounds absurd, until you look at the pixelation of space-time at the Planck length. If space is pixelated, and time is discrete, and complexity is capped, then the universe is a computation. And the Jade's anomaly is a stack overflow error. We are looking at the blue screen of death of the early cosmos. There is a biological analogy to be made here. Neoteny, the retention of juvenile traits. But the universe shows the opposite. Progeria, premature aging. The universe aged rapidly in its infancy. It grew up too fast. In biology, rapid growth usually comes with a cost. Cancer, instability, early death. In cosmology, the cost of this rapid growth might be the stability of the vacuum itself. A universe that builds galaxies this fast is a universe running hot. It burns its potential energy quickly. This supports the idea that we are living in the end times of the stellar era. The peak of star formation is long behind us, at redshift 2 cosmic noon. But the new data says cosmic dawn was also a peak. We missed the morning rush and the lunch rush. We are dining in an empty restaurant at 3 a.m. The party is over. The entropic principle revisited. If the universe produced heavy elements this early, then habitable planets could have formed 13 billion years ago. This is the ancient life hypothesis. Earth is 4.5 billion years old, but a planet around a star in Jade's GSZ 13-0 could be 13 billion years old. If life started there, it has a 9 billion year head start on us. Imagine a civilization that has had 9 billion years to evolve. They would not be biological anymore. They would be part of the physics, they would be indistinguishable from magic. Perhaps the dark matter that holds the galaxy together is not a particle, but the technological infrastructure of these ancients. We are looking for dumb particles, but we might be weighing the Dyson swarms of the first gods. The silence of the universe is not empty, it is encrypted. The flux of the signal tells us about the star formation rate density. It's off the charts, but there is a limit to how much gas you can turn into stars before the heat stops the process. It's called feedback. The feedback in these galaxies seems to be broken. The gas keeps falling in, stars keep turning on. It's a runaway reaction. Runaway reactions in nature usually end in explosions. This suggests the early universe was a chain reaction of galactic ignitions. It wasn't a slow dawn, it was a flashover. Like a room reaching auto-ignition temperature. The whole universe caught fire at once. We are the soot left over from that fire. The carbon in your hand is the soot. We are the ash of the initial flashover, trying to understand the fire that burned us. We need to talk about the void again. We assume space is empty. But quantum mechanics says space is a seething foam of virtual particles popping in and out of existence. Zero-point energy. Did the early galaxies tap into this? Some fringe theories suggest vacuum energy could be harvested or influence gravity. If the high density of the early universe coupled with the vacuum energy, it could produce white holes, time-reversed black holes spitting matter out. Are these bright galaxies actually white holes? Mathematical curiosities that we thought were impossible. A white hole would look like a brilliantly bright object that cannot be entered. It would explain the energy output without needing stars. We might be seeing the exhaust ports of the Big Bang, spewing matter into our dimension from elsewhere. The crisis is also a crisis of faith in our tools. We rely on redshift to measure distance. But what if redshift has a component we don't understand? Intrinsic redshift. Halton Arp proposed this decades ago, that young matter is born with high redshift and it decreases over time. He was ostracized. But if he was right, the universe is not expanding and these galaxies are not far away. They're just young and small and nearby. It would shatter cosmology. It is unlikely, but the fact that serious scientists are rereading Arp's papers shows the level of desperation. When the building is shaking, you check the foundation, even the parts you thought were solid rock. If redshift is misinterpreted, we know nothing. We are measuring the universe with a rubber ruler. The pair instability supernova mechanism deserves more detail. When a massive star dies, it usually collapses. But if it's too massive, the core gets so hot that photons turn into electron-positron pairs. This drops the pressure, and the star collapses. The collapse triggers a nuclear explosion so powerful it unbinds the entire star. No remnant, no black hole, just a cloud of expanding metal. A universe filled with these explosions would be chaotic, filled with shock waves. These shock waves would collide, compressing gas to form more stars, a chain reaction of death and birth. The impossible galaxies might be the nodes of these shock waves, places where the overlapping explosions of the first generation force the second generation into existence. A universe born from the shock waves of its own suicide. Dark stars. This is a theoretical object made of normal matter but powered by dark matter annihilation in the core, not fusion. They would be puffy, cool, and gigantic. As big as the orbit of Saturn, they could shine for millions of years before collapsing into black holes. Could Jade's GSZ 13-0 be a cluster of dark stars? If so, we are seeing dark matter directly for the first time. We are seeing it burn. This would prove dark matter is not just a gravitational ghost, but a fuel source. A universe powered by the annihilation of its own shadow. It would explain the brightness and the temperature. But it implies dark matter is much more interactive than we want it to be. If it can burn, it can change. And if it changes, the galaxy holding us together might one day evaporate. The horizon problem asks how opposite sides of the universe are the same temperature if they never touched. Inflation solves this by expanding a tiny point to the whole cosmos. But the impossible galaxies suggest inflation might have been bumpy. If inflation didn't smooth everything out perfectly, it left, quote, isocurvature perturbations, wrinkles in the sheet. These wrinkles would grow into massive galaxies instantly. But wrinkles in space-time are dangerous. They can be cosmic strings, defects in the fabric of reality, infinitely thin but massive enough to slice a planet in half. If the early universe was full of defects, we might still have them floating around. Invisible lassos of gravity whipping through the void. We haven't found one yet, but the clumpy early universe suggests they should be there. The Great Silence. We look at these galaxies and see power, but we don't see signals. No radio waves yet, just thermal radiation. But if civilizations rise fast, they also fall fast. The Berserker hypothesis. Ancient machines destroyed the early civilizations. Maybe the reason the universe looks natural now is because it was sterilized. The reionization epoch was not stars clearing the fog, it was a weapon clearing the competition. It sounds like paranoia, but when you see impossible growth, you have to ask what drove it. Competition drives growth. War drives technology. Was the early universe a war zone? The peace of the modern era might be the peace of a graveyard after the battle is over. We are the moss growing on the ruins. The cosmic web is the largest structure in the universe. Filaments of dark matter connecting galaxies. The jade's discovery implies the web formed instantly. It didn't weave itself slowly. It snapped into existence. This supports the phase transition idea. Like water freezing into ice, the structure appeared all at once when the temperature dropped. If space-time can freeze into a web, can it melt? If the universe heats up again, will the web dissolve? The structure we rely on is temperature-dependent. We are ice skaters on a frozen pond, and we just found out the ice formed in a split second. It suggests a fragility to the solid ground of reality. If it came fast, it can go fast. The lithium problem is an older mystery that connects here. The Big Bang predicts 3 times more lithium-7 than we see. Where did it go? Maybe it was consumed by the impossible galaxies. Population 3 stars destroy lithium. If there were enough of them to create the metal-rich signal we see, they could have eaten the missing lithium. It solves one mystery by creating a bigger one. Where are the corpses of these lithium eaters? We should see their black holes. The missing baryon problem states we can't find half the normal matter in the universe. Maybe it's locked in the black remnants of this first violent generation. The universe is hiding half its mass in the dark, in the graveyards we can't see. Let's zoom out to the multiverse. String theory suggests $10 carat, $500 possible universes, each with different laws. Maybe our universe is a bubble colliding with another bubble. A bubble collision would inject energy into a specific region, creating a hot spot. A spot where galaxies form too fast. Is the Jade's region a bruise from a collision with another universe? If so, we are not alone. We are bumping into neighbors. The dark flow, mentioned earlier, could be the gravity of the other bubble pulling on us. We are not an isolated island. We are a ship in a crowded harbor, bumping into other hulls in the fog. The impossible galaxy is the dent in our hull. The information paradox. Black holes destroy information, supposedly. If the early universe was full of direct collapse black holes, vast amounts of information about the Big Bang were deleted, swallowed. We are trying to reconstruct the history of a book where half the pages have been shredded. We will never know the initial state of the universe because the evidence was eaten. This cosmic censorship might be a feature, not a bug. Maybe the universe prevents us from seeing the naked singularity of the beginning. It hides its origin behind an event horizon. We are allowed to see the result, but never the cause. The sheer number of photons hitting the JWST sensor is small, a few hundred. We are building a civilization-altering theory on a handful of particles. This is small number statistics. It is dangerous. But the particles are consistent. They all tell the same story of the Lyman break, the drop-off in light that confirms the distance. The consistency is what scares us. If it were random noise, it would look like noise. It looks like a signal that says, your model is too simple. The universe is not a sphere of uniform gas. It is a complex living beast with a history of violence we have forgotten. Time dilation. At redshift 13, time moves slower for us observing them. If you watched a clock in that galaxy, it would tick 14 times slower. But for them, it is normal. This relativistic distortion means we are watching a movie in slow motion. The violence we see, the explosions, the collapse, is happening 14 times faster in reality. The fury of the early universe is dampened by the expansion. If we could be there, the rate of change would be blinding. We are watching a slow-motion replay of a car crash. The crash was instant. The destruction was total. We are just analyzing the debris flight path. The UV luminosity function. This graph plots how many bright galaxies exist. The line should drop off as you go brighter. It doesn't drop off fast enough. The line stays flat. There is an excess of bright things. It's like walking into a forest and finding that every tree is a redwood. No saplings, no bushes, just giants. It implies an ecosystem that only supports giants. What kind of physics suppresses the small and boosts the large? Perhaps tides. Strong gravitational tides in the early universe ripped small things apart, leaving only the massive survivors. A Darwinian filter of gravity. Spectral hardness. The light from these galaxies is hard, high energy. It suggests very hot stars. 50,000 degrees Kelvin. Our sun is 5,000. These are blue hot torches. They emit enough energy to strip electrons off atoms light years away. A planet orbiting such a star would be sterilized by UV radiation in seconds. No ozone layer could protect you. It reinforces the idea that the early universe was uninhabitable. It was a sterilizing oven. We are the mold that grew after the oven turned off. Life is a post-cooling phenomenon. We missed the hot era, and we should be thankful. The mass-to-light ratio. Usually we weigh a galaxy by its light. But if the initial mass function is different, our scale is broken. We might be overestimating the mass, or underestimating it. If these galaxies are actually lightweight but just very bright flare-ups, then the crisis is solved. But to be this bright without mass requires exotic physics. Super-Eddington accretion again. It's the difference between a steady fire and an explosion. We might be looking at explosions and calling them fires. But an explosion is a transient event. These objects seem stable. A stable explosion is a paradox, unless the explosion is the galaxy. The clustering of these galaxies, they are not randomly distributed, they are found in groups, protoclusters. This means the seeds of the cosmic web were already in place. The blueprint was drawn before the bricks were laid. This implies primordial non-Gaussianity again. The universe had a plan, a structure. Where did the plan come from? Quantum fluctuations during inflation. The random jitter of subatomic particles became the map of the galaxies. We are walking through a magnified quantum fluctuation. The macro is the micro writ large. The largest things in the universe are just echoes of the smallest things. The James Webb has a limited lifespan, 10 years, maybe 20. We have a brief window to solve this. The signal is here now, but as the universe expands, the signal gets redder, fainter. Eventually, it will shift into the radio spectrum and vanish from Webb's view. We are in a golden age of observation. In a few billion years, these galaxies will be redshifted beyond detection for any optical observer. Future civilizations will not see them. They will think the universe has no history. We are privileged to see the evidence before it is erased by the expansion. We are the witnesses to the crime before the body washes away. Cosmic dawn. The name implies a gentle sunrise. The data implies a sudden blinding flash. Cosmic flash would be more accurate. The transition from darkness to light was instantaneous on cosmic scales. This suggests a trigger, a catalyst. What triggered the first stars? Shock waves? Dark matter decay? The timing is suspicious. 200 to 300 million years. Why then? Why not earlier? Why not later? It coincides with the cooling of the gas to a specific temperature. The universe waited for the precise moment it was cool enough to burn. A thermodynamic trigger. A time bomb set to go off when the temperature dropped below 1000 Kelvin. The mystery of the missing dwarfs. Where are the small galaxies? JWST sees the big ones. The theory says there should be millions of small ones. Are they too faint, or did they not form? If the universe made only big galaxies, it violates scale invariance. Nature usually makes things of all sizes. If it only made giants, it means there was a cutoff scale, a minimum size for existence. This implies a quantized nature to gravity or space-time in the early epoch. You couldn't be small. You had to be big or nothing, a binary existence. Dark energy, revisited. The cosmological constant problem, the worst prediction in physics. Theory predicts vacuum energy should be $10 carat, $120 times stronger than observed. The impossible galaxies might be the clue. Maybe vacuum energy was stronger in the past, driving the rapid growth, and then decayed to its current weak value. If vacuum energy decays, what does it decay into? Matter? Radiation? Did the decay of the vacuum create the galaxies? We might be made of the rot of the old vacuum. We are the precipitate of a decaying dimension. The axis of evil. An anomaly in the CMB. A cold spot and an alignment of features that shouldn't be there. It points to a specific direction. The Jade's galaxies also seem to align with large-scale structures. Is the universe anisotropic? Does it have a north pole? If so, the laws of physics might change depending on which direction you look. We assume symmetry. But nature loves to break symmetry. If the universe has a direction, it implies a rotation, or a flow, or a gradient. We are not in a uniform box. We are on a slope. And we are sliding. The end of science? Some argue that if the universe is truly infinite and chaotic multiverse, we can never find a theory of everything. We can only find the theory of here. The Jade's anomaly pushes us towards this discomfort. The rules that work here don't seem to work there in time. If physics is local, then universal truth is a myth. We are gathering data about our specific prison cell, thinking it describes the whole prison. It doesn't. The cell next door might have 0 gravity. The cell down the hall might have 5 dimensions. We are mapping the wallpaper of our cage. The Fermi paradox again. If the universe started with a bang of life-enabling metals, why did it take 9 billion years for Earth? Maybe it didn't. Maybe there were billions of Earths. But gamma-ray bursts from the violent early galaxies sterilized them. The universe was a shooting gallery. We survived because we arrived late, after the shooters ran out of ammo. The quiet of the universe is the silence of a ceasefire. We are the children of the armistice. The war happened before we were born. Entropy, the arrow of time. The early universe had low entropy, high order. But a field of black holes has high entropy. The impossible black holes mean entropy spiked way faster than predicted. The universe degraded faster. We are closer to the heat death than we thought, because the black holes accelerated the march towards disorder. They are entropy engines. They ate the order of the Big Bang and spat out chaos. We are living in the chaos they left behind. Gravitational waves. The collision of these early giants should send ripples through space-time. Pulsar timing arrays are trying to detect the background hum of these waves. The Jade's discovery predicts a loud hum, a cacophony of merging black holes. If we detect this hum, it confirms the violence. We will essentially hear the screams of the early galaxies devouring each other. The universe is ringing like a bell struck by a hammer. We are just now putting our ear to the metal. The mirror universe. Some theories suggest a universe of antimatter moving backward in time was created at the Big Bang. CPT symmetry. The impossible galaxies might be the interaction point between the two. Is the energy leaking from the mirror twin? It sounds like sci-fi, but mathematics allows it. A twin universe, paying for our free lunch. If we touch, we annihilate. The wall between us is time, and we are looking back at the wall. We stand at the halfway point of our investigation. The impossible early galaxies have dismantled our timeline, threatened our physics, and hinted at a violent, terrifying prehistory. They are the anomalies that cannot be ignored, They are the black swans of cosmology. But we must go further. We must ask, if the past is broken, what does that mean for the future? If the universe grew up too fast, will it die too young? The signal from 13.5 billion years ago is not just a history lesson. It is a prophecy. And the prophecy says that stability is an illusion. The monster is real, and it is waiting in the dark matter that binds us. The existence of these impossible galaxies drives a wedge into the heart of the Hubble tension. This is the most significant disagreement in modern physics. One method of measuring the universe's expansion, using the cosmic microwave background, gives us a value of 67. Another method, using nearby supernovae, gives us a value of 73. They do not agree. The gap is statistical impossibility. It's a 5 sigma error, meaning the chance of it being a fluke is 1 in millions. We hoped the James Webb telescope would resolve this by refining the measurements. Instead, the discovery of JADE's GSZ 13.0 suggests that the early universe was behaving in ways that might invalidate the microwave background method entirely. If the early universe was clumpier and more violent than the smooth model predicts, our baseline calibration is wrong. We are trying to measure the length of a room with a ruler that is shrinking while we hold it. If the 67 value is wrong, and the universe is actually expanding faster, then the age of the universe is younger. We might be shaving a billion years off the cosmic timeline, compressing all of evolution into a tighter, more frantic window. The walls of history are closing in. Let's discuss the local void. We live in a region of space that is relatively empty compared to the rest of the universe. This is the KBC void. Some scientists argue that because we live in a bubble of nothingness, matter is flowing out of our region towards the denser parts of the universe. This outflow mimics rapid expansion, tricking us into thinking the whole universe is accelerating. If the JADE's galaxies represent the true density of the universe, then our local void is even emptier than we thought. We are living in a cosmic ghost town, a hollow shell. The impossible density of the early universe is the norm. We are the anomaly. We are the underdense freak of nature. It implies that life might only be possible in these quiet, hollow voids, far away from the chaotic, deadly density of the real universe. We are hiding in the attic while the party rages downstairs, terrified of the noise. There is a radical alternative to dark matter, known as MOND, modified Newtonian dynamics. It suggests that gravity behaves differently at low accelerations. For decades, MOND was the underdog, mocked by the mainstream. But the impossible early galaxies are a victory for MOND. In a MOND universe, structure forms much faster because you don't have to wait for dark matter to clump. Gravity simply works stronger and faster on galactic scales. If MOND is right, then dark matter, the substance we've spent billions of dollars hunting, does not exist. It is a mathematical fiction, like the luminiferous ether of the 19th century. It would mean our understanding of gravity, from Newton to Einstein, needs a patch. It implies that the laws of physics are not universal but scale-dependent. Gravity changes its mind depending on how hard it pushes. A fickle force for a fickle universe. The role of primordial magnetic fields is often overlooked. In the Standard Model, magnetic fields are generated by the spinning of stars and galaxies, the dynamo effect. They appear after the structure. But what if the universe was born magnetic? A strong primordial magnetic field would act as a stiffener for gas clouds, helping them resist expansion and collapse faster into stars. It would be the invisible skeleton that allowed the JADE's galaxies to stand tall so early. But where would a universal magnetic field come from? It implies the Big Bang was an electromagnetic event as much as a gravitational one. It suggests the universe has a polarity. If the cosmos is a giant magnet, are we moving along the field lines? Are we just iron filings arranged by a force we haven't bothered to measure on a cosmic scale? The impossible structure might just be the shape of the magnetic cage we are trapped in. We often speak of the cosmic dark ages, but perhaps we should call them the blinding ages. If the star formation rate was truly this high, the ultraviolet background radiation would have been intense. Any observer present in that epoch wouldn't see a black sky. They would see a glowing fog. The universe was a neon sign. This intensity has implications for panspermia, the spreading of life between planets. Intense UV light destroys DNA. It sterilizes dust grains. If the early universe was a UV oven, then the complex molecules needed for life would have been broken down as soon as they formed. The building blocks of life would have been incinerated. This reinforces the idea that life is a late-stage infection of the universe, something that could only take hold once the fires burned down and the cosmos grew cold and dark. We are the mold on a cooling corpse. The concept of ancient aliens takes a darker turn here. If planets formed 13 billion years ago around these metal-rich stars, they are gone now. Their stars have died. Their galaxies have merged. But if a civilization survived, they would have had to leave their home. They would become Type 3 nomads, moving between stars, perhaps even harvesting black holes. The Great Silence might be because these ancients have moved to a medium we cannot detect. Maybe they uploaded themselves into the vacuum fluctuations. Maybe they are the dark matter. We look for radio signals, but they might be operating on the substrate of space-time itself. We are like ants looking for pheromones while humans communicate via Wi-Fi above our heads. The impossible galaxies are their ancestral homes, long since abandoned. We are digging through the ruins of gods. The stochastic gravitational wave background. This is the hum of the universe. Every time two black holes merge, they chirp. Billions of mergers create a static hiss. The impossible galaxy data implies this hiss should be a roar. The early universe was a cacophony of merging holes. Pulsar timing arrays are on the verge of detecting this. When they do, we will hear the sound of the early universe eating itself. It will be the soundtrack of our origin, not a choir of angels, but the grinding of space-time as monster eats monster. If the roar is too loud, it could even disturb the stability of precision timing in the galaxy. The violence of the past echoes forward, shaking the very fabric of the present. We are standing on a floor that is vibrating from an earthquake that happened billions of years ago. Consider the standard sirens. Gravitational waves from colliding neutron stars give us a direct distance measurement, bypassing the messy ladder of candlelight and redshifts. We haven't heard enough of them yet. But the Jade's discovery predicts we should hear more of them from the deep past. If we don't, it means the neutron stars weren't there. That would mean the early mass wasn't in stars, but in black holes. Direct collapse. It forces us back to the black hole first theory. The universe didn't light up, it darkened down. The primary inhabitants of the early cosmos were singularities. The lights we see, the stars, are just the decorative moss growing on the edge of the abyss. The universe is fundamentally a machine for making black holes, and stars are just the inefficient byproducts. The geometry of the universe is assumed to be flat. Parallel lines never meet. A triangle has 180 degrees. But this is an assumption based on the cosmic microwave background. The impossible galaxies hint at a higher density. High density can curve space. If the universe is closed, shaped like a sphere, then if you travel far enough, you return to your starting point. But a closed universe is doomed to recollapse. The Big Crunch. If the early universe was this dense, we are dancing on the edge of the critical density that triggers the collapse. The expansion might just be the upward trajectory of a ball thrown in the air. It slows down, stops, and falls back. The signal from the past is a reminder of the density that wants to pull us back into the fire. Gravity never sleeps, it only waits. Eternal inflation. The theory that our universe is just one bubble in a sea of inflating space. In this model, new universes are constantly being born. The impossible galaxies could be the result of our bubble having a rough start. Maybe our bubble collided with the parent vacuum during its birth, injecting extra energy. This bruise became the seeds of the first galaxies. We are living in a damaged universe, a scarred bubble floating in a multiverse of madness. If true, the laws of physics are just the local bylaws of our specific bubble, subject to change if we bump into another one. The impossible nature of our history is evidence that our genesis was not clean. It was a violent, messy birth in a crowded nursery. Let us contemplate the sheer loneliness of the void between these early galaxies. In the modern universe, galaxies are grouped in filaments. In the early universe, they were islands in a sea of neutral darkness. If you were on a planet in Jade's GSZ 13-0 and you looked away from the galactic core, you would see nothing. Absolute blackness. No other galaxies. The light from neighbors hadn't had time to reach you yet. You would think you were the only object in existence. The psychological terror of that isolation is profound. It is the ultimate solipsism. A civilization arising there would have no concept of cosmology, no concept of a universe. They would think their galaxy was the entirety of creation. How much of our own science is limited by what we can't see? What is hiding behind our own horizon? Fuzzy dark matter (FDM) offers a psychedelic solution to the anomaly. If dark matter is made of ultralight particles, their quantum wavelength could be light years long. This means the galaxy is not filled with particles like sand. It is filled with a superfluid wave, a giant quantum blob. This wave behavior suppresses small structure but enhances the formation of dense cores, exactly what we see in Jade's GSZ 13-0. It means the galaxy is a soliton, a single solitary wave packet of matter. We are walking through a universe that behaves like a liquid on the grandest scales. The clumping is just the interference pattern of these waves. We are not particles. We are foam on the crest of a dark matter wave that is crashing through eternity. Self-interacting dark matter, SIDM. Standard dark matter passes through itself like a ghost. SIDM crashes into itself like billiard balls. If dark matter interacts, it can transfer heat. This dark heat would puff up the centers of galaxies, making them less dense. But the Jade's galaxies are more dense. This pushes back against SIDM. It forces us to a frightening conclusion. Dark matter is cold and collisionless, yet it clumps faster than gravity allows. This implies a fifth force, a force that only dark matter feels, a dark electromagnetism, a shadow sector of physics that is complex and rich, invisible to us but pulling the strings of the cosmos. We are the puppets of a shadow world we cannot touch. The core cusp problem. Simulations predict that dark matter halos should have a sharp, dense cusp at the center. Observations of modern galaxies show a flat core. It's a mismatch. But Jade's GSZ 13-0 seems to have that dense cusp. It matches the simulation. This suggests that the early universe was pure theory, and something happened later to flatten the cores. What happened? Baryonic feedback. Exploding stars pushed the dark matter out. But to push dark matter, which only feels gravity, you need to move a lot of mass. It implies the history of the universe is a history of explosions violent enough to reshape the invisible skeleton of the galaxy. We live in a remodel, a renovation built on violence. The pristine shape of the early universe was ruined by the very stars that light it up. The missing satellites. Theory says the Milky Way should be swarming with thousands of tiny dwarf galaxies. We only see a few dozen. Where are they? Did they never light up? Are there thousands of dark galaxies hovering right next to us, invisible because they have no stars? The Jade's discovery complicates this. If star formation was so efficient back then, the dwarfs should have lit up. They should be visible. The fact that they are missing suggests they were destroyed, cannibalized. The Milky Way grew by eating its children. The impossible galaxy likely grew the same way. We are looking at the survivors of a galactic battle royale. The emptiness of our halo is the silence of a graveyard after the feast. The too big to fail problem. We see dwarf galaxies that are surprisingly empty of dark matter, while theory says they should be dense. It's another crack in the standard model. But the high redshift galaxies are too big to exist. We have problems on both ends of the scale. Small things are too empty. Big things are too full. The universe is defying our curve at every point. This suggests that gravity is not scale invariant. The rules change when you get big, and they change when you get small. We are trying to use one equation for everything, but the universe might be running different software for different scales. A fractured reality where consistency is a myth. Let's return to MOND, modified Newtonian dynamics, because the implications are philosophical. If MOND is true, there is no dark sector, no dark matter, no dark energy, just gravity. But it requires us to abandon Einstein. It requires us to say that general relativity is an approximation, valid only in the solar system. It means we have been worshipping a false idol of physics for a century. The resistance to Mond is fierce because it feels like a step back. But the impossible galaxies are forcing us to look at it. If we strip away the dark sector, the universe becomes naked and raw. The behavior of the galaxies is intrinsic to them, not dictated by an invisible ghost. It makes the universe more knowable, but far stranger in its behavior. The speed of gravity. We assume it equals the speed of light. If the sun vanished, Earth would orbit for 8 minutes before flying off. But in some modified gravity theories, gravity can be instantaneous or propagate differently. If gravity traveled faster in the early universe, it would explain the rapid clumping. Superluminal gravity, it breaks causality. It means effects can happen before their causes are seen. It breaks the timeline. If the early universe had superluminal gravity, then the past and future were entangled in a way they aren't today. The arrow of time was blurry. We might be looking at an epoch where time itself was not yet a hard directional vector, a chaotic temporal soup. Variable g, Newton's gravitational constant. The g in the equation, we assume it is a rock-solid number, but string theory suggests it plays a role in the geometry of extra dimensions. If the extra dimensions were shifting in the early universe, quote, could have been stronger. A stronger g means faster collapse, brighter stars, quicker death. It solves the Jade's mystery perfectly. But a changing g is terrifying. If it changes, planetary orbits are not stable. Stars are not stable. If g drifts by even a tiny percent today, Earth could spiral into the sun or drift into the cold. The impossible galaxies suggest g was different then. Will it be different tomorrow? We are walking on a tightrope where the tension of the rope is constantly changing. The fine structure constant, alpha, it determines the strength of the electromagnetic force. It determines how atoms hold together, how light interacts with matter. Measurements from distant quasars have hinted that alpha might vary across the sky, a dipole in the laws of physics. In one direction, electromagnetism is stronger. In the other, weaker. If Jade's GSZ 13-0 sits in a region of strong alpha, stars would burn brighter and hotter. Life chemistry would be different. Impossible here, possible there. If the constants vary, then there is no standard model. There is only a local model. We are provincials, assuming our village rules apply to the empire. They don't. Quasars are the lighthouses of the deep past, supermassive black holes eating gas. We see them at redshift 7, redshift 8. Now we suspect they are at redshift 13. To power a quasar, you need a fuel tank, a massive accretion disk. The Jade's galaxy is likely a quasar host, but a quasar is a death ray. It emits jets of plasma at near light speed. If one of those jets was pointed at Earth 13 billion years ago, we wouldn't be here. The universe was crisscrossed with these death beams. Navigation in the early universe would be suicide. It was a minefield of active galactic nuclei. We survived because the mines ran out of fuel. The safety of the modern night sky is an illusion caused by the exhaustion of the monsters. The Lyman Alpha Forest. When we look at a distant quasar, we see a forest of absorption lines caused by hydrogen clouds between us and the light. This forest maps the skeleton of the universe. The impossible galaxies should be clearing this forest. We see transmission spikes, holes in the forest, bubbles of clear space. This confirms the Swiss cheese model of reionization. The universe didn't clear up all at once. It was punched full of holes by these galaxies. We are living in one of the holes that eventually merged with all the other holes. The void is the structure. The matter is just the wall of the cheese. We define reality by the stuff, but the universe is mostly the empty space created by the burning of the stuff. Warm dark matter, WDM, a compromise between cold and fuzzy. WDM particles move fast enough to smear out small structures but slow enough to form big ones. It suppresses dwarf galaxies. It helps explain the missing satellites, but it struggles to explain the dense cores of Jade's GSZ 13-0. To make that dense core, WDM needs to be just right. The Goldilocks dark matter. It feels contrived. Nature is rarely contrived. Usually, when we have to fine-tune a theory this much to make it fit the data, the theory is wrong. We are adding epicycles to Ptolemy's orbits. We are trying to save the model, but the model is dying a slow death by 1,000 data points. Sterile neutrinos. A hypothetical heavy neutrino that interacts with nothing, not even the weak nuclear force. It only has gravity. It is a leading candidate for dark matter. If the early universe produced these via Dodelson-Withrow mechanism, they could decay into X-rays. We see an unexplained X-ray background in the universe. Is this the song of the sterile neutrino? If the Jade's galaxies are held together by these ghosts, they are pockets of decay. The very glue of the galaxy is unstable. If the dark matter decays, the galaxy flies apart. Are we watching the slow evaporation of the gravitational glue? Will the Milky Way eventually unwind as its dark matter turns into X-rays? Axions, another candidate. A particle predicted to solve a problem in quantum chromodynamics. Axions could convert into photons in a strong magnetic field. Primakov effect. If Jade's GSZ130 has a strong magnetic field, maybe some of its light is not starlight, but axions turning into light. Dark light. We might be seeing the dark matter glowing directly. This would be a revolution. It would mean the dark sector is luminous if you know how to look. It blurs the line between matter and energy, between light and dark. The universe is not dualistic. It is a spectrum of transformation. The WMP miracle. Weakly interacting massive particles. The favorite theory for 30 years. We built massive detectors deep underground, xenon elux, to catch them. We found nothing. Zero. The silence is deafening. The Jade's discovery puts another nail in the coffin. WIMP models struggle to make early massive galaxies. The miracle is turning into a nightmare. We bet the house on WIMPs, and we lost. Now we have no leading theory. We are drifting in the dark without a compass. The impossible galaxies are mocking our failure to identify the majority of the universe. We are incompetent detectives in a cosmic mystery. Supersymmetry. SUSY. The beautiful theory that every particle has a heavy partner. It was supposed to solve everything. The Large Hadron Collider was supposed to find it. It didn't. Nature is not supersymmetric. It is messy. The Jade's anomaly fits a messy universe, not a symmetric one. The elegance of our equations is a human projection. The universe does not care about mathematical beauty. It cares about functionality. It builds monsters because it can, not because it fits a symmetric group theory. We are learning that beauty is not truth. The truth is ugly, heavy, and fast. The desert in particle physics. The gap between the energy scales we can test and the energy of the Big Bang. It is a vast wasteland of no new particles. We hoped for an oasis. We found a desert, but Jade's GSZ130 is a sign that something lives in the desert. High-energy physics that we can't replicate on Earth was happening naturally back then. The early universe was the ultimate particle accelerator. It smashed particles at energies we can only dream of. The impossible galaxy is the debris from that accelerator. We are doing archaeology on the result of an experiment we are too primitive to run ourselves. The Grand Unified Theory, GUT. The unification of strong, weak, and electromagnetic forces. It happened in the first fraction of a second. The energy released by this symmetry breaking could have driven the inflation that seeded the Jade's galaxies. Cosmic strings are topological defects from this era. If we find a cosmic string lensing one of these galaxies, it proves GUT. We are looking for a crack in the glass of space-time, a line where the mismatched tiles of reality meet. Finding one would be the Holy Grail. It would let us see the plumbing of the universe. The theory of everything. 2OE. Unifying gravity with quantum mechanics. We don't have it. The singularity inside a black hole is where we need it. The Big Bang is where we need it. The Jade's galaxies are the closest we can look to the Big Bang. They are the stress test for any potential TOE. If a theory can't explain Jade's, it's trash. The anomaly is the gatekeeper. It stands at the entrance to the Temple of Truth and demands a password we don't have. Until we explain the impossible galaxy, we don't understand gravity. Period. String theory describes a landscape of vacua, mountains and valleys of potential energy. Our universe rolled down into a valley. But did it roll into the deepest one? Or are we stuck in a high valley? A false vacuum. The violence of the early universe suggests we tumbled down a chaotic slope. The impossible galaxies might be the splash marks from when we hit the bottom. Or we are still rolling. The expansion is the roll. And there is a cliff edge ahead. The swampland conjecture says most string theories don't work. Ours does, barely. We are navigating a swamp of mathematical impossibilities, and Jades is a monster rising from the muck. Loop quantum gravity, LQG. An alternative to string theory. It says space is made of discrete loops. Space atoms. It predicts that at high densities, like the early universe, gravity becomes repulsive. It bounces. A big bounce instead of a big bang. If gravity bounced, it would create shockwaves. The Jades galaxies sit exactly where those shockwaves would deposit matter. Are we seeing the signature of the bounce? If so, the universe is eternal, expanding and contracting, a cosmic lung breathing in and out forever. We are just one breath in an infinite life. Causal set theory. Space-time is a discrete causal network. Events are nodes. The impossible galaxy represents a dense cluster of nodes. In this theory, the continuum of space is an illusion. It's all dots. If the dots are connected too tightly, you get a black hole. The early universe was a small world network. Everything connected to everything. Information traveled instantly. This explains the uniform temperature and the rapid growth. We were all neighbors once, in the network of the beginning. Expansion is the breaking of those links. Isolation is the price of growth. Emergent gravity. Eric Verlinde's idea. Gravity is not a force, it is entropy. It is a side effect of information scrambling. Like heat. If gravity is emergent, it might not have emerged fully in the early universe. The laws of gravity were still booting up. The impossible galaxies formed under a different entropic regime. It's a terrifying thought. Physical laws are not eternal commands. They are habits the universe learned over time. And habits can be broken. If entropy changes, gravity changes. The glue of the universe is biodegradable. It from bit, Wheeler's phrase. The universe is made of information. The Jades signal is a data stream, a bit stream from the past. We are decoding it, but what if the file is corrupted? The redshift stretches the bits. The noise adds errors. We are reconstructing a corrupted file and finding a monster. Is the monster real, or is it an artifact of the decompression algorithm, our theory? We might be projecting our own fears into the static, but the static is so loud it feels physical. The information density of that galaxy is higher than allowed. It's a zip bomb of reality. The black hole information paradox. Hawking said info is lost. Quantum mechanics says it's saved. The firewall hypothesis says the event horizon is a wall of fire. The early universe was packed with these firewalls. Did they burn the information of the pre-universe? If Jades GSZ 13-0 contains black holes formed from direct collapse, they are pure black holes. They contain the raw information of the Big Bang vacuum. If we could look inside them, we would see the code of the matrix. But the firewall keeps us out. We are locked out of the server room. ER equals EPR. Entanglement equals wormholes. Space-time is stitched together by quantum entanglement. The early universe was highly entangled. This means wormholes were microscopic and everywhere. The Jades galaxies might have formed around wormhole clusters, tunnels in reality. If matter could cheat by taking shortcuts through wormholes, it could clump faster than light allows. We are looking at a universe that cheated. It used cheat codes to build galaxies. But as the universe expanded, the wormholes snapped. The shortcuts are gone. We are playing the game on hard mode now. Non-locality. Quantum particles affect each other instantly across distances. Bell's theorem. If the entire early universe was a single quantum state, then everything affected everything. Holism. You couldn't separate the Jades galaxy from the rest of the cosmos. It was all one thing. The separation we see now, here versus there, is the illusion. The impossible galaxy is just a knot in the blanket. You pull the knot, the whole blanket moves. We are pulling the knot, and our physics is unraveling. Retrocausality, the future affecting the past. Wheeler's delayed choice experiment. Our observation now might be determining the state of the photon then. Are we, by observing Jade's GSZ 13.0, forcing it to exist? Did the universe stay in a quantum superposition of dead and alive until we built the Webb telescope and collapsed the wave function? It's the ultimate ego trip. We created the past by looking at it. But if we created it, why did we create a monster? Why did our subconscious manifest an impossible galaxy? Perhaps because we fear the dark, so we filled it with fire. The block universe. Past, present, and future exist simultaneously, a frozen block of 4D crystal. In this view, the impossible galaxy is not long ago, it is over there. It exists right now, at coordinate t equals 300 million. It is an eternal feature of the block. We are just sliding our consciousness along the time axis. The horror is that the block is static. The violence of the early universe is frozen forever. The screams never stop. The explosion never ends. We are just moving away from the heat. Presentism. Only the now W is real. The past is gone. Jade's GSZ 13.0 does not exist. Only the light exists. The photons hitting the mirror are the only reality. We are inferring a ghost. We are building a history out of echoes. If the past is truly gone, then we have no origin. We simply are. The impossible galaxy is a story we tell ourselves to explain the light. But the story is getting incoherent. Maybe the light has no source. Maybe the universe was created last Thursday, with the photons already in flight. It's unfalsifiable and terrifying. The growing block. The past is real, the future is not. The edge of the block is the present. We are the leading edge of reality. We are the creators of time. But the Jade's galaxy is at the bottom of the block. It is the foundation. If the foundation is cracked, impossible physics, can the tower stand? We are building the future on a past that makes no sense. A structural failure in the basement eventually brings down the penthouse. The anomaly in the deep past destabilizes our confidence in the deep future. Many worlds interpretation. Everett. Every quantum event splits the universe. The early universe had infinite quantum events, infinite splitting. We are in one branch of the wave function. In other branches, maybe Jade's GSZ 13.0 didn't form. In others, maybe it ate the whole universe. We are in the Goldilocks branch, where it was just scary enough to be interesting but not deadly. But there are branches where Earth never formed. We are surfing the probability wave of survival. The impossible galaxy is a reminder of how many ways this could have gone wrong. Quantum Darwinism. The fittest quantum states survived to become classical reality. The Jade's galaxy was the fittest structure. It outcompeted the others. It monopolized the gas. It killed the competition. The universe is a product of ruthless selection pressures at the quantum level. Survival of the densest. Survival of the brightest. We are the descendants of the winners. And the winners were monsters. We carry that lineage. The violence is in our protons. Quantum immortality. You can never experience your own death. The consciousness always shifts to the branch where you survive. Maybe humanity has survived 13.5 billion years of cosmic threats because we are trapped in the survival branch. The impossible galaxy represents a threat that wiped out 99% of the other timelines. We are the outliers who watched the bullet miss. We interpret it as luck or impossible physics, but it's just the selection bias of consciousness. We are the only ones left to be confused. Boltzmann brains. In an infinite universe, it is more likely for a single brain to spontaneously fluctuate out of the vacuum, complete with false memories of a history, than for an entire universe to evolve. The impossible galaxy data is so weird, so unlikely, that it increases the probability that we are Boltzmann brains. The universe is too complex to be real. The glitch of the Jade's galaxy is a hint that the simulation is low effort. A real universe would follow laws. A hallucination follows dream logic. And this looks like a dream. The heat death. Entropy maximizes. The lights go out. The Jade's galaxy was the first match struck. We are watching the match burn. The fuel is limited. Every star that burns brings us closer to the end. The impossible efficiency of the early universe means we burned a lot of fuel early on. We wasted our inheritance in the first billion years. The peak star formation is over. We are living in the winding down. The universe is an engine that is slowly running out of gas, and we just realized we drove the first 100 miles in first gear, redlining the engine. The Big Rip. If dark energy increases, it tears galaxies apart. Then stars. Then atoms. The impossible galaxy suggests dark energy might be dynamic. If it spiked once to create these monsters, it can spike again to destroy them. We might not have billions of years, we might have millions. Or thousands. If the phantom energy takes over, the sky will go dark. Not because the stars died, but because they were ripped away from us faster than light. The signal is the first tremor of the phantom. The Big Crunch, the opposite. If the density is too high, and Jade says it is, gravity wins. The expansion stops. The universe reverses. Blue shift. The sky gets hot. The microwave background turns into an oven. We get cooked. The impossible galaxy is the heavy anchor that will drag us back down into the singularity. We escaped the fire once, but gravity is a rubber band, and it is stretched to the limit. The snapback will be the end of time. Vacuum decay. The ultimate catastrophe. A bubble of true vacuum nucleates. It expands at light speed. It rewrites the laws of physics. Inside the bubble, chemistry is impossible. Matter collapses. We wouldn't see it coming, we would just cease to exist. The violent energies of the early universe, the energies that built Jade's GSZ 13-0, might have weakened the fabric. They might have poked the bear. We are living in a metastable state, walking on thin ice over a deep, dark ocean. The signal from the past is the sound of the ice cracking, and we are standing right in the middle of the pond.